Hi, this is Professor Gina. I'm making a short video to answer some of your questions about the worksheet that was assigned on Tuesday from the packet, pages 38 and 39. So I'm going to go through a couple of examples. The first example is a prism. It's not one that I assigned, but it's the same concept. What we're trying to do for the first page, page 38, is verify Euler's formula. And so we're doing it in two different ways, one with the prisms and then also with the pyramids. So in this case, a decagonal prism has a decagon, which is a 10-sided figure, as its base. So let's figure out what the number of faces are for this particular figure. We know that for any prism, we're going to have two bases, a top and a bottom, right? For all of the prisms. And then the lateral faces is going to match the number of sides in the base shape. So since a decagon has 10 sides, this is a 10-sided figure, that means that we're going to have 10 of those rectangular faces on the sides. So we're going to have 2 plus 10 in this particular case. And then for the edges, I know that I've got 10 edges along the base, both on the top and also the bottom. So that's going to be 20. And then I've got all of these edges along the side, and there are going to be 10 of those. So it looks like I've got 30 of those. And then as far as the vertices are concerned, I'm going to have 10 vertices along the top, and then I'm also going to have 10 vertices along the bottom. So I think I'm going to have a total of 20. So for this particular figure, if we do V minus E plus F, the number of vertices we said was 20, the number of edges was 30, and the number of faces was 12. And if we add those together, we should get 2. So that verifies Euler's formula. Now, taking that idea and extending it for any prism, which is the last line of the table that you're filling out, for any prism, and n means that we have a figure that has n sides as the base. The number of faces is going to be n, that's for all the lateral faces along the sides, and then plus 2, one for the top and one for the bottom. The number of edges is going to be 3 times n. I've got n of them along the bottom, n along the top, and then n along the sides. And in the example we just had, we had 10 on the bottom, 10 on the top, and 10 on the sides. And then for the vertices, we're going to have 2 times n. I had 10 on the bottom for vertices and 10 on the top. So let's see if this can be verified in the Euler's formula. So the number of vertices is 2 times n. The number of edges is 3 times n. And then the number of faces is n plus 2. If I combine all of these together, those are going to cancel each other out to just be 0. And it looks like I'm ending up with equaling 2, which is Euler's formula. So this shows that it's true for any prism that we come across. For the second example, I'll look at a pentagon. This is a pyramid, a pentagonal pyramid. That's a tongue twister. All right, for this example here, the number of faces is, I've got 1 as a base, and then I've got 5 triangles as the lateral sides, so a total of 6. The number of edges is I have 5 along the bottom down here, right? And then I have 5 along the sides like that. So 5 plus 5 gives me 10. And then for the number of vertices, I have 5 down on the base, and then I have 1 up at the top. So that's going to be a total of 6. So let's verify V minus E plus F. So we have 6 minus 10 plus 6, and that equals 2. So that works out. So let's think about any pyramid. For any pyramid, the number of faces is going to be n plus 1. I know that I'm going to have n, which would be the number of triangular faces, and then plus 1 is from the base. The number of edges will be 2 times n. I had 5 edges along the base, and then I also had 5 edges along the side. And the number of vertices is going to be n plus 1. I had 5 vertices along the bottom and then 1 at the top for the apex. So let's see if we can put these together to verify the formula. We have n plus 1 for the vertices minus 2n plus n plus 1. So let's look at this, this, and this. Those total up to be 0. And then if I look at this and this, that ends up giving me the 2. So that shows that it's true there as well. All right, let me just check time real fast. I think I have time to do one more example. Yeah, okay. Let's look at one of the examples from page 39. Let's look at number 7. This is page 39, number 7. Suppose a prism has 15 edges. How many faces does it have? Well, we just saw that for a prism, the number of edges is going to be n times 3. So for any prism, the number of edges is 3 times n. So that means that n in this case has to be 5. So that means that our base shape is a pentagon. So in that case, the total number of faces is going to be 2, 1 for the top and the bottom, and then plus 5, because I'm going to have 5 rectangles on the side. So I think our answer is 7. All right, if you have additional questions, send me an email, and thanks for watching.